All right, y'all. So 3.7 deals with systems of inequalities. And y'all remember, inequalities are your less than, greater than, less than and equals, and greater than and equals. And we're doing linear inequalities, so these will all be straight lines. So the trick is to graph the equation. Once we graph the equation, we need to figure out what kind of line and how we're going to shade it. Because the inequality can have more than one solution. Okay, so once we got it ready to graph, we need to figure out what kind of line we're going to draw. So if you got less than or equals or greater than or equals, you're going to use a solid line. And that solid line means if it's on that line and it's solid, then that is also solutions to the inequality. If it's less than or greater than, so if it does not have equals on it, then we will use a dashed line. So any solutions that are on the dashed line make it false. So it's only true on the line if we use a solid line. So these tell us what kind of line to use. And in MathLab, you'll have to choose on MathLab whether you got a solid line or a dashed line. So now we've got to figure out, do we shave above the line or below the line? So if it's greater than and equals or greater than, we're going to shade above the line. If it's less than or equals or less than, then we're going to shade below the line. So these two will tell us where to shade. Now in MathLab, when you want to shade, they'll have a little paint can looking thing. So you get the paint can, drag it where you need it on the graph, and let go, and it'll shade what area you need. Okay, so we're going to be doing these by hand. So we figure out what kind of line we're going to draw, and then we're going to shade where we need to. Now remember, anything you shade, if you check the answers, the region you shade has to make that true when you put it back into the inequality. So the first four is just getting you used to graphing lines. And then question number 5 will be one that we actually graph a system, which will have 2 equations. So we're going to start out with just single equations. So these will say graph the inequality. So for number 1, I'm going to do y greater than x minus 4. And then I'll show you how, as long as you got to solve for the y, it's pretty easy to do on the calculator. So I'll do this by hand, and then I'll show you how to do this on the calculator also. So this one's already solved for y. So I would come straight down and get my table ready. So since these are straight lines, we need at least 2 points. So y'all, I'm just going to use a 0 and, oh, I can use a 1. All right, so we put a 0 in for the x. 0 minus 4 gives me a negative 4 for the y value. And I treat it like I'm using the equals while I'm figuring out these values. And then I'll worry about that when I start graphing that line, okay? So let's put a 1 in for the x. If I put a 1 in for the x, 1 minus 4 gives me a -3. So now I've got 2 points. So let's go get ready to graph it. All right, so let me plot my 2 points first. I got 0, -4. So 0, -4 will be straight down 4 on the y-axis. Then I got 1, -3. So go right to 1 and down 3. So I've got my second point. So the first thing I need to figure out, do I want a solid line or a dashed line? So since we got greater than, up here it says if it's less than or greater than. So let me see what my cat's got going on. All right, so chat's saying dashed, and that's correct. So we would make a dashed line through here. So then, do I want to shade above or below? All right, so let's see. So good job. We got greater than, and it says if it's greater than, equal, or greater than, we shade above. So when you shade above, we're going to come in and shade everything above that line. So anything that's shaded, if you plug it back in, makes that true. So pick any point. So here's a point right in the center. That's 0, 0. So if I put zeros in for checking, 0 is greater than 0 minus 4, which is 0 greater than -4. Well, that's definitely true. So since that's true, we know we shaded the right area. Okay. You know, not too bad on the calculator. I'm going to pull up my calculator and show you all how I would do this on there. You know, what I would do is go to my y equals, and I'm just going to plot in the x minus 4. So I'm going to do x minus 4. So that's the equation. Now, the only thing, y'all, on the calculator, it won't do the dashed line and the solid line, but it will shade. Now, if you want to shade, we're going to arrow all the way left with the cursor. So see, I'm moving left of the equals. Once you get on the left side of the Y1, it's going to blink, and I'm going to hit enter. I'm going to hit enter until I got what looks like a triangle above, which is this one that I'm showing right now. So that's the shade above. I'm going to hit enter again. The triangle on the bottom is the shade below. So that's how you would shade above and below using them triangles. Let me enter all the way through until I get back to the triangle above. So now that I'm telling it to shade above, all I got to do is hit grass. And it'll shade just like our problem look, okay? Now, y'all, I'm going to switch my calculator and do it in the color enhanced version because they graph different. So let me switch calculators. So let me go to y equals. I'm going to clear that out. And I'm going to put in my x minus 4. Now, I'm going to arrow all the way left like I did on that one. So arrow the cursor left. And it blinks over there where I got a blue box and a line. If I hit enter on that, it's going to pull it up. It says, well, what color do you want? So I can go through here, pick a color. So I'll do green. Arrow down on line. When you arrow down on line, go left or right until you get the triangle. There you go. This triangle is the triangle above. Arrow down and hit OK. Now it's going to do my shading in green above the line when I hit grass. So they both do the same thing. It's just how do you get to it, okay? There you go. So let's knock out number 2 here. Three x minus 5y is less than or equal to a negative 20. All right, so the trick on this one is to solve that for the y. Once we solve it for the y, then we can find our points and start graphing it. So I'm definitely want to solve that for y. So we need to get that negative 5y by itself first. So we're going to subtract 3x from both sides. And y'all, that'll bring down my negative 5y. Less than or equal. Now you can't add the negative 20 and the negative 3x. So I'm just going to put my negative 3x and then minus my 20. I just usually put the x's first so it looks like that y equals mx plus b form of a line. All righty. Now we need to turn negative 5y into a 1y. So we're going to divide everybody by negative 5. Now, do y'all remember the rule for inequalities when you divide by negative numbers? Let me see what my tab is. All right, so let me remind y'all. When you're solving an inequality, oh, there you go, flip the sign. So since it was less than or equals, when you divide by negatives, it now becomes a greater than or equal. So reverse the inequality when dividing by negatives. Okay? Only when you divide by negatives, okay? So these negatives cancel, making that a positive y greater than or equal. These negatives cancel, making that a 3/5 x. These negatives cancel, making that a positive 4. At this point, now you could graph it in your calculator if you wanted. Because we now have it solved for the y. So y'all let me find 2 values. All right, so I'm gonna use 0 again. I like 0. So 3/5 times 0 is 0. 0 plus 4 gives me 4. Now, I'll probably be picky on this number. I want a number that'll cancel with that 5. So I'm going to use 5 for my next x. So let me show you why I did that. So that would be 3/5 times 5 plus 4. So by using the 5, I can cancel out the fraction. And that basically turns into a 1. So that gives me 3 plus 4 and that'll give me a 7. So when X is 5, Y is 7. But y'all remember, you can graph this, and MATLAB would give you nice numbers to plot on the graph if you didn't want to use fractions, okay? All right, so here we go. We got 0, 4. So 0, go up 4. I'm gonna make my Y just a little taller. 5, 7 would go right to 5, up to 7. That's sitting about where I was writing that problem. All right, so solid or dotted line? All right, so remember what I'm looking at is this inequality. There you go. Since I got some equals under that, it definitely will be a solid line. And then do y'all want me to shade above or below? So what you got to watch out for, always look at the inequality on the equation you solve, okay? So since this one is greater than, we'll shade above. There you go. And just shade that in and be done with it, okay? So really, if you look at it, this section sort of gives you more practice graphing lines also. All right, so I'm gonna throw a curveball. This one says X greater than -4. Now, the thing you notice on this, and if you was going to make you a chart, now this one, unfortunately, we can't do in a Y equals because this is only a X. So you're not going to be able to do it in Y equals. Some calculators have that option, but most of ours don't. So when you got a graph like this and it's only got one variable in that number, that means that the X has to be -4 no matter what Y values are here. So this is like X equals -4. X always has to be -4. And then you can pick any two Y values. But look here. X must be -4 for every point. And what's going to happen when you got X equal to some number, this is going to be a vertical line. So I'm just going to pick any two Y values. I'm going to keep them small using 0 and 1. So we would come over here, -4, 0 would be right on the X-axis. -4, 1 will be right above it. So MATLAB, once you put that second point, it's going to draw you a vertical line. So here's the question. Is my vertical line going to be solid or dashed? Well, definitely going to be dotted. Good job. Now on the X, you really don't have a above and below. So for X, when it's greater, would y'all shade to the right or to the left? Oh, let's see, I got one of these. So remember, X's get greater to the right. There you go. So we would shade to the right here. So that any X value that's in this shaded area is greater than the X value of a -4. So y'all remember, on the X's, they're vertical lines. So now we will look at the Y. All right, so this would be like our number 4. Y is greater than or equal to a -2. All right, so the Y lines, when you don't have the X variable and it's just a Y, these will be horizontal lines. So if you was to make a little chart on this one, every Y value would be -2. So Y values must be -2. Now we can pick any two X's. So I'll do my 0 and 1 again. So if it's an X here, the X's had to be what the number was. When it's a Y here, the Y has to be that number. And when we graph this, you'll notice it'll make a horizontal line. And then this one I'll show you on the calculator because it can do the Y's, just not the X's. So here's my 0, -2. So 0 go down 2. And then I did 1, -2. So go right 1, down 2. So solid or dotted? All right, so I'm seeing solid, good job. That line will go straight across. Shade above or below? And above. So we would shade above that line. So that anything shaded, those Y values will be greater than -2. Okay, also watch this, and I'm gonna go to the calculator real quick. So on that one, on Y equals, I'm gonna clear that out. So I was Y greater than -2 or equal. So I'm just gonna put -2 in here. I'm gonna go arrow all the way left. Well, we're shading above, right? So it's already highlighting on above. So since mine's already got the triangle above, I can go straight to graphing it. And there you go. Horizontal line with shading above it. And I want to go back one more time and do it on the old calculator. So let me go to Y equals, clear that out. Now on the old one, when you hit clear, it clears away the triangles. So when you put in your -2, you're going to have to arrow left and then hit enter until we get the above triangle. So now it's got the triangle above. Now I can hit graph and it goes straight across. You know, not too bad. So now there's only one problem doing this. but we're going to solve a system of inequalities. The main thing when you're solving a system of inequalities with two inequalities, the solution is the double shaded region of the graph. So I'll shade one line, then I'll come in and shade my other line, and where they overlap is the solution to this problem, okay? So this will be like y'all's number 5. Y greater than or equal to x plus 1. Y less than or equal to 1 minus x. So we'll do this by hand, and then I'll show you what I was talking about on the calculator, okay? So let me get my graph ready. And I guess I'll use my markers to sort of shade these so y'all can see the different shades. So first, let me graph this line. I'm gonna get a few points, plot that first line. Then we'll get a few points and plot that second line. So I'm just gonna use the easy points, 0 and 1. So if I put a 0 in for the x, 0 plus 1 will give me 1 for the y. If I put my 1 in for that x, 1 plus 1 is 2. All right, so I'm gonna graph my first line. So, solid or dotted? All right, so good job. That will be solid because of the equals. So let's see, 0, 1 will be right there. Right 1 and up 2 will be right there. So you said this line was solid. Next question. Would that one shade above or below? So remember, that is greater than. And greater than shaded above. So you would come in and shade above the line. All right, now let's play with this one. This one is y less than or equal 1 minus x. I'm going to make me a little x and y table for that one. And I'm just going to use 0 and 1 again. If I put a 0 in there, 1 minus 0 is 1. If I put the 1 in for the x, 1 minus 1 is 0. So let's see, my second line has 0, 1. So that's the same point as we'll go. And then 1, 0 would be right 1 and 0. Solid line again because it's equal. All right, so question on this one, shading above or below? So there you go. Since it is less than or equal, it is below. So we shade below that line. So can y'all tell where the double shaded area is? It looks like it's this section right in here. What's my marker dead? So this area right over here. So anything in this section makes both of these inequalities true. Okay. Anything up here might make one true, but it's not making the other one true. So the actual solution is where they double overlap. And I'll show you that on your calculator. They're pretty fun on the calculator. So let me share that. So I'll do this one and then I'll go to the other. So equation 1 was x plus 1. And on equation 1, I'm going to arrow all the way left. Equation 1 shaded above. So I'm going to hit enter until I get my triangle above. Then I'm going to go down. Equation 2 was 1 minus x. And it's shaded below. So I'm going to go left and shade it below by hitting enter until I get that triangle below. Right there you go. All right, y'all, when we graph it, we're looking for the double shaded region. But if you notice over here, it's pretty evident that it is that left side. So here, I'm going to do that one on this color calculator. All right, so go to y equals. I'm going to clear that. And I'm going to put x plus 1. Now it's shading above, so I'm just going to leave it green since it's already shading above. I'm going to arrow down and put in my 1 minus x. Arrow left. Hit enter. So look, that's going to give me red, and it's shading below. Remember, just click down and it'll give you options on changing those. Go down and click OK. All right, so when we graph it, we're looking for the double shaded area between the green and the red. So it almost made it look sort of orange, brownish orange looking color, but that on the left side is our double shaded region. So we're not going to kill you on those. We just wanted y'all to do one of those just to see what a system of inequalities would look like, okay? All right, so y'all remember 3.7, which we just covered, is the last material for test 1. What I'm about to show you is 7.1. This is the start of test 2 material. And this is dealing with symmetry. So this is the start of test 2 material. Now, and I'm only doing it like this so that we can use Wednesday for a review for test 1, okay? But I want to make sure we can get through that review with y'all. So y'all familiar with words like symmetry? Like the left side of your body is sort of symmetric to the right side of your body. They sort of look the same. So when we're looking at graphs, there's 3 types of symmetry we're sort of concerned with. And y'all, this is a little bitty section. I think it's only got 5 homework problems. The first symmetry we're worried about is what we call symmetric. To the x-axis. So to be symmetric to the x-axis, so let me show you one that is. So to be symmetric to the x-axis, if you fold the graph over the x-axis and it lands on itself, then it is symmetric to the x-axis. So notice, if you use to fold this along the x, this top part of the graph would land right on the bottom part of the graph. So it's landing on itself. So if folding along the x-axis and the graph lands on itself. Okay, well, that's how I check my x. I just pulled it over. If it hits itself, symmetric to the x. Next, we're looking at symmetric to the y-axis. So let's see. I'm going to draw a little parabola, I guess. So to be symmetric to the y-axis, if I take my graph and fold it over the y-axis and it lands on itself, then it is symmetric to the y-axis. So it folding along the y-axis and the graph lands on itself. Also, here's another thing. If they're symmetric to the y-axis, we call them even functions. What that means is usually graphs that make these kind of shapes will have even exponents, okay? Like the parabola, which is x squared, x4 graphs will do this, and so on. So those are what we call even functions. So y'all, that was the x, the y. The last one we're looking at is what we call symmetric to the origin. So remember, the origin is the center of the graph. So let me draw one of those. Let's see, these would come up, would cut through the middle, and then go up. Now we're not folding it this time. To be symmetric to the origin, if I rotate the graph upside down and I get the same picture, it is symmetric to the origin. So if rotating the graph, and to turn it upside down, we say you're rotating the graph 180 degrees. So if rotating the graph 180 degrees, and we have the same graph. So I drew one on black and white for you. So y'all watch this. My graph is going uphill left to right. I'm going to flip it 180 degrees. And my graph is still the same graph going uphill left to right. So by rotating it and getting the same graph back, okay? Now, these are what we call odd functions. So to make these kind of graphs, you want to have odd exponents like cubes to the fifth and so on. All right, y'all. So what I'm going to do is draw a few pictures, and we're going to determine if they're symmetric to the X, the Y, or the origin. All right, so for my number one, oh, y'all, this will be tricky. It comes up, and then down here, it sort of does that. This side comes down, and then this side sort of does that. So, y'all, what y'all think? X-axis, Y-axis, origin. Oh, that's pretty quick. Oh, God. So let's see. It's not the X, because if I fold it on the X, this part lands down here, and this part, let's see. It's not the Y, because if I flip it over to Y, this part still hits up here, so it's not landing on itself. But notice that picture. If you take that picture, turn it upside down, we still have the same picture. So good job, y'all. That is definitely the origin. All right, what do we think about number two? Oh, y'all are quick. That is definitely the Y. If I fold this graph over the Y-axis, this part will land on top of this part. So it's definitely the Y-axis. All right, what do we think? Yeah, good job. If I take the graph, fold that thing over that X-axis, this top part will land on that part. So there you go. X-axis. All right, so let me throw a curveball and ask you this. Determine if even, odd, or neither. Well, this is what 4 and 5 will do to you. So let me draw 4 here real quick. All right, so 4, they got doing this. It's coming over, going down, coming over, it's going down. And I'll show you another trick to finding this. So remember, it's symmetric to the Y, so y'all are pretty quick. Since it's symmetric to the Y, we said a while ago that symmetric to the Y made these even. But y'all check this out. You can also tell by how many times it touches the X-axis. This touches 1 time, 2 times. So since it touches 2 times, which is an even number, it is definitely even. Or look at the symmetry. So if it's symmetric to the Y, it's even. Symmetric to the origin, it would be odd. Alrighty, y'all, this one's sort of tricky. Let me see. Goes up and down. Then it comes down and up. Then it goes out. This side comes down and up and over. Then it comes out. Oh yeah, so yeah, so X would be neither, because remember, let me show y'all. Remember, if it's symmetric to the X, it's not even what we would really call a function because it fails our vertical line test. So that's why we don't worry about that X-axis. Oh, good job. Y'all are saying odd because it's symmetric to the origin. Also, look at this. 1, 2, 3, 4, 5. It touches the X-axis 5 times also, which is odd. So that is definitely an odd function. All right, that's all I got for today. So remember, Wednesday, we're going to come in here and do our test 1 review. I'll open test 1 Wednesday, but y'all, since I missed that day, the due date for test 1 actual test is like October 2nd. I think I got it. But I wanted to make sure we practice this Wednesday. That way y'all can do this, because this, remember, this counts as a quiz grade. Okay. And this has 25 questions on it. Wednesday, I'll let you know which 5 I took off and which 20 I kept. So you want to really do this review until you get a good score. Once you get a good score, then knock out that test, okay? But I wouldn't do the review, make a bad grade, and then try that test. It'd not be bad, okay? So this you can do as many times as you want. The test only has 1 attempt, okay? All right, y'all, let me make sure. I'm going to make sure I got everybody logged in here. All right, I've got y'all. So y'all, any questions? So I'm sort of keeping this week a little mellow because we're reviewing for that test, okay? All right, so I don't see no questions. So y'all, here's what, knock out your 3.7. Okay, so the test will have a 90-minute test, 90-minute time limit. And its final due date on that test 1 is October 2nd. So it's not this Sunday, but the next. It originally was due this next Sunday, but since I missed that day, that sort of threw us off a little bit. And we'll start new material before it's due, but that way y'all can have time to do your study guide, get good on it, then hit that test. Because remember, these tests make up 50% of the grade in this class. That's a pretty big chunk of it. So y'all do good on these tests, and then you're going to have an easier time getting through, okay? All right, y'all, any more questions? All right, I'll see y'all Wednesday, and we're mainly doing review, and that's it, okay?